Okay, let's dive right into this explainer and unpack the totally invisible architecture that organizes our entire digital lives. I mean, think about it. Every time you scroll through social media, book a hotel, or even just casually check your bank balance, there is this massive, highly structured world operating just beneath the surface. Today, we're going to make that hidden world visible. We'll demystify what your data actually is, how it transforms, and why the systems we use to manage it have essentially become the most critical infrastructure of the modern age. But before we get into the complex software systems, we really have to start at the very foundation. We have to ask, what is your data really? Interestingly, the word data actually comes from the word datum, which just means a single piece of information. At its absolute most rudimentary level, computer data is just a bunch of ones and zeros, binary code. It's raw facts and figures. It could be numbers, an audio clip, an image file, or literally just your height and weight. And because it's digital, it can be transferred instantly and stored forever without losing quality. But here's the catch. On its own, it doesn't really mean much of anything. So to see how those ones and zeros actually become useful, here's our roadmap for this explainer. We're going to go from data to information, look at the major flaws of early file systems, explore the arrival of the DBMS, cover its main advantages, and finally, discuss the actual cost of using a DBMS. All right, Section 1. From data to information. We need to figure out exactly how we bridge that gap between a totally meaningless string of numbers and something you can actually use. The core mechanism making this happen is essentially a pipeline. You start with data at the very beginning, those raw, unprocessed facts we just talked about. Then, it gets pushed through a process step, usually a software program, which organizes and refines everything. Finally, it spits out information. Information is the actual meaningful result. It's the part that finally answers the who, what, where, and when. There's a really sharp contrast here that we need to understand. Raw data is inactive and heavily technology-based. It's just facts sitting in storage. But information is processed, active, and business-based. It's what actually enables humans to make decisions. So, for example, the number 101 and the name Hari, well, those are just data. But Hari lives in house 101 in Chit 1. Now that is information. Moving on to Section 2, the file system flaws. Because for decades, managing all this processed information meant relying on physical filing cabinets or really basic flat electronic file systems. And honestly, it was a massive headache. These old flat file systems were quite literally a nightmare for organizations. I mean, they were riddled with severe drawbacks. You had data isolation, meaning your files were scattered everywhere in totally incompatible formats. You had a heavy dependency on specific application programs. So if you tweaked a file structure, you had to rewrite the entire software. And the security? Incredibly poor. Setting access constraints was so difficult that a student could accidentally open a file containing a teacher's private payroll details. But the absolute biggest offenders were redundancy and inconsistency. So here's why that matters. Data redundancy directly causes data inconsistency. Imagine a college where a student is taking 2 different courses. In an old flat file system, that student's address gets saved twice in 2 completely separate files. Now, if the student moves and asks to update their address, an administrator might change it in the first file but completely forget about the second one. Instantly, your system is corrupted. You've got inconsistent data, and you literally no longer know which address is the truth. Flat file systems also terribly failed at something called atomicity. Atomicity is the strict all-or-nothing rule for data transactions. When a transaction takes multiple steps, either every single step has to complete perfectly, or the entire process has to cancel and revert back to exactly how it started. Flat files just couldn't guarantee this. Let's look at why that is absolutely crucial with Steve's bank transfer. Steve wants to send $100 to Negan. This takes 2 steps. Debit Steve's account, then credit Negan's account. But, as we all know, computers crash. If the system crashes right after Steve's account is debited, but before Negan gets credited, what happens? In those old systems, rolling back that error was incredibly difficult. The money just vanished into a digital limbo. No way. Which brings us to Section 3. Enter the DBMS. Just when managing data felt entirely hopeless and companies were terrified of these costly errors, a powerful solution emerged to finally bring some order to the chaos. Enter the Database Management System, or DBMS. Now, the DBMS isn't the data itself. It's a highly sophisticated collection of software programs that manages the data stored in a database. Think of it as an incredibly intelligent bridge standing right between a massive, complex database structure and the end user or application. It creates this incredibly unified environment where the centralized DBMS acts as the ultimate hub. It seamlessly connects desktop apps, mobile devices, and servers, routing everything through one central intelligence. It completely hides all those messy, complex storage details from you, the user, while fiercely protecting the integrity of the entire data network. And you interact with these systems every single day. When you check if a hotel room is open for the weekend, a DBMS is instantly querying its tables. When your power company calculates your complex monthly billing, or when Facebook is processing social graphs, messages, and ads for billions of users all at the exact same time, that is a highly robust DBMS. It's the hidden engine making all of those dynamic, real-time interactions possible. Let's jump to Section 4, Advantages of DBMS. Why did the entire world switch to this new, complex architecture? Let's break down the tangible benefits. The upgrade is huge. Where file-based systems bogged you down with storage details, a DBMS gives you a clean, abstract view. Where old systems couldn't handle that Steve and Negan bank transfer crash, a database has built-in crash recovery using robust backup protocols. And through a process called normalization, a DBMS actively strips out that dangerous data redundancy we talked about earlier. It fixes the student address dilemma. Beyond just crash recovery, the core advantages are immense. By enforcing strict access constraints, the system makes sure your private data is fiercely secure. Users only see exactly what they're allowed to see, which prevents data leaks. It also ensures really fast response times for easy access, even when the database gets massive. Plus, it's highly flexible. The system can easily scale up storage or add new tables without breaking the data structures you already have in place. But moving to Section 5, the cost of DBMS. In this explainer, we want to look at the whole picture, and this digital hero definitely has its own vulnerabilities and costs. With all these incredible features, atomicity, rock-solid security, zero redundancy, we really have to ask, is implementing a DBMS always the perfect, flawless choice for every single organization out there? Well, no. The reality is that these advantages come at a pretty steep price. First, the implementation cost of a DBMS is way higher than just setting up a simple file system. Second, the sheer complexity is intense. Organizations have to invest heavily in technical training, often hiring dedicated database administrators just to keep the whole thing running. And third, because database systems are generic, meaning they're built to be suitable for a wide variety of applications, this one-size-fits-all nature can actually slow down performance for certain highly specific applications that might just run faster on a simpler setup. Yet, despite the massive financial costs, the steep learning curve, and the need for specialized admins, the general consensus is pretty clear. As the source material so bluntly puts it, since data are very important to the end users, we must have a good way of managing data. The absolute sheer volume of our modern information simply demands that we use these robust systems just to keep everything intact and secure. Which brings us to the future. Data never stops growing. It only accelerates. So I'll leave you with this provocative thought. As our digital footprint expands endlessly, what happens when the complex databases we currently rely on become too massive to manage? Take a moment the next time you open an app to appreciate the hidden, fragile architecture tirelessly spinning behind your screen. Thanks for joining me on this explainer, and keep exploring the systems that run our world.